Hi, in this video series we're going to take a look at how to create Legos in 3D. We're going to cover some good planning for topology and making subdivision surface modelings. We're going to look at how to bridge together pieces of alternating geometric styles, square, round, or rounded. We're also going to look at how to texture these objects appropriately, build an entire Lego creation, and look at how we can create Lego presets so that we can pull from a digital box and apply textures again from a set of presets that we'll create along the way. So we'll be covering modeling, texturing, and assembly of these things along with rendering and setting up some scenes. So to get started, we're going to create just a single block, and this will be the building block, no pun intended, for our future pieces. Some pieces we'll want to start from scratch, but a lot of them it will be a lot easier to just begin with these pieces. So you can Google Lego block dimensions and find some good measurements online. But since I've already done that, I'm just going to key in the ones that I know I need for a basic block size, and that's 8 millimeters across and front to back on the Z and on the X, and then 3.2 millimeters high. I find that most things have to do with multiples of 1.6 millimeters, so we'll kind of be using that as the base here. So I'm going to click apply, and then we'll have our single unit block in the viewport ready to be used in subdivision surfaces. Now one thing we'll notice obviously immediately when we hit subd's, the tab key, we're going to turn into our lovely M&M shape, and of course that's not what we wanted. So we'll need to use some loop slices to sharpen up those edges and give us something more appropriate. So I'm going to drop my cube tool, and with Alt-C or Option-C, I'm going to start making my loop slices. Let's maximize this view so I can see all three corners here. So what I will do is, let's try this again, loop slice. Let's select our polys and then loop slice. We'll put in a couple this way. We'll put in a couple this way. And finally we'll put in a couple this way. And that now gives us, when you look, you can see this kind of quad shape here on the corners. And this is what we're looking for. With a subdivision surface, if we want to keep something sharp, what we'll want to see is an edge that defines the actual physical edge, and then we'll need edges on any side surface that will sharpen up that edge, like this edge here or this edge here. All right, so now we'll look at how to add on a circular piece on top of that. Okay, so there are a couple of ways that we can add something circular onto here. And using subdivision surfaces, remember that anything with even sides is going to come out circular. However, we do want to kind of define that circle in order to make it look good and to make it look convincing. So we can just bevel off of this in one piece to get a circular surface, but we can also divide up this cube and give us a more appropriate bridge point to attach a circular surface for the top here. Now there are a number of ways that you can divide this up. You can, if you add in one edge through the middle of each of these, so using loop slice, if we go and add one onto each of these, we'll have now 8 sides, 2 on each side, that we can attach a circle to. That can work relatively well. I think actually what I'm going to do here on this one though is go with 2 edges on each side. So if I set my down to 2 in uniform, those will pop in, and the same thing there. So now I have a dozen sides, and that will help a lot because often we're going to be wanting to decrease the subdivision level on these in order to get a lighter render. And remember, subdivision surfaces are often going to be rendered with surfaces that will adaptive subdivision, so the closer you get, the more polygons are there. And so it's not really going to matter too much how many polygons are in the base here. But this will allow us, so if we're unsubdivided completely, we'll still have a pretty nice look to our round section. So that's going to be important, because if we get this far out, you know, or this far, where this piece is pretty small, we're not really going to need a lot of subdivision. But if we're only dealing with 4 or 8 sides, it's definitely still going to look kind of rough and segmented. With more sides, with a dozen sides like this, we'll probably have a much cleaner look here, and we'll have a look at that in a minute and see how that works. Okay, so now that we have this properly divided up, we need to create that little beveled section on top so that we can attach it. So I'm going to go to my cylinder tool, and I'm going to type in my dimensions. I know that that the radius on these, remember we're dealing with radius, so we have to cut any dimension in half. These are 4.8 millimeters wide, the little bumps that are on the top. So we need to type in, enter 2.4 millimeters, and they are 1.6 millimeters high, so again, we'll do half of that, and 0.8 millimeters on the height, and then again 2.4 millimeters there. And if I hit apply, oops, and let's see, oops, I also need to set, my segments down, my sides down to 12, my segments to 1. So now I'm going to hit apply, and looks like we got something glitching here a little bit. Oops, there we go. It's because we've got it off-centered and with the wrong count here. So let's cut those out. Again, we'll go to this and we'll make sure we zero out our position, and then we'll click apply, and it's going to drop our, oops, we see I've actually got it facing down the wrong axis. So let's back up, make sure it's going down the Y, and then we'll click apply, and we'll have our cylindrical piece in here. Now we're going to grab that and we're going to move it up, and we're going to move it up 2.4 millimeters to get it centered. That looks right. Yep. Okay, and then another thing that we'll notice, well, two things. One is that if we're going to be bridging this to the piece underneath it, we're not going to need the bottom of it. So I'm going to drop my tool here, then I'm going to deselect the top and the sides, cut out the bottom. And the other thing is that if we just look at the alignment of points here, we can see that we have a middle point here, 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 and here, whereas the middle on each of these sides of the cube are edges. So we're going to want to rotate this to align edge to edge. Oops, so let's select the entire thing, rotate, and it's going to be 15 degrees, either positive or negative, just depending on the way you would like to rotate. And with that done, I'm now ready. I'm going to hide this piece, and then I'm going to select and then shift up arrow to select the outer edge of poly, so I get all 9 polygons in the middle here. And we'll cut those out, and then we'll unhide our middle. We're also going to need to subdivide that since it's going to be connected to a subdivision piece. And then I can select the boundary there just by holding down Control and clicking on Edges. Again, I'm going to go select this outside edge. So if we go over to Lists, we should see how many sides we have selected. And it should be 12. We can see down here. We have 12 edges selected, and then when we select all of this, it should double to 24. And that's a good thing to check anytime you're going to bridge. You want to make sure that you're bridging the same number of polygons or edges on either side of your bridge. So on each piece of connective geometry, you want to check that count. You can do it with alternating counts, one side being different than the other, but it really comes out with results that aren't ideal. You'll get some twisting, and you'll get some triangles that aren't going to be clean, especially when, in this case, we can very easily make these sides agree. So I'll go down to Edge, and I'll select Bridge and click out here. And initially, we're going to see this really smooths out our geometry, obviously, too much. So we'll want to start by doing a couple of loop slices around the cap here. And I like to pull these all the way out initially because they're going to get tightened up later by some other additions to polygons, and then we can scale them down to get them more appropriate. And then I'm going to select here, and I'm going to add another set of subdivisions, but I already had 2 in my count on my subdivisions. I'm only going to need the inner one, so I'm going to delete that one. And now I'll get this nice corner still here. And this is a point where you actually will get a high valence point where you'll have 5 edges coming into one point. However, since this entire surface is all these polygons are coplanar, meaning they're existing on one flat plane, that's not going to cause us any issues. High valence points are more of that needs to be adjusted when they exist on a curved surface, some surface that is not perfectly level as this one is. And the same thing goes with n-gons. Here we have this n-gon on the top, but this isn't really gonna bother us much here. I'm gonna add an extra edge here, and I'm just gonna bevel in a little bit. I'm gonna go in about 100 just to give a little bit of extra definition on the top so that it kind of matches the definition that's on the bottom here. Now, one thing, if you look at these pieces, you'll notice that the rounding here on these edges, the outer edges of the brick, and the rounding on both the top and the inner cusp of these bumps is a little bit different. So I'm going to go to my scale tool with those two edges selected. I'm just going to pull them down a little bit. I think about 85%. You can see in the Y direction looks right. Now we're getting some rounding here and also some rounding up here, and that will be a little bit more accurate. Actually, I think I'm going to pull it down just a little bit more. We'll go to 80%. Now I get just a little bit more rounding. And now you can see if I unsubdivide this, we're still getting a relatively good circular surface here. So this is going to work pretty well if we're out of sub D or if we're in sub D. Okay, and like I said, if we're out here, being out of sub D's is not gonna hurt us at all. Once we get in and closer, obviously we'll want sub D's on. But if we're using adaptive subdivision, that will clear up a lot of that manually. Or if we're really short on render resources, we can always unsubdivide them entirely. We're going to get a pretty decent surface anyway. If we've done this with 8 sides, an octagon is very noticeable as a polygon. People are going to notice that octagonal shape very quickly. With 12 sides, not so distinguishable. You can see even here at this point, you get a little bit of faceting, but that you're getting a linear, or those linear pieces are coming together pretty well to give us a curved surface. You get much smaller than that, and you really have a hard time telling the difference, especially if we quickly turn off. Let's go to model single here that I have my wireframes off. You know, the difference becomes much less noticeable, especially when we'll add anti-aliasing on a finished render. You're really not going to notice too much on the difference there. And you can see it drops from 350 or to 356 polygons from 5600 if you're here at full subdivision. All right, so let's go to our quad view again, and we're ready now to create the bottom of this section. So to do this, we're going to have to let's unsubdivide actually, and we're going to need to bevel this section in. Now, one thing to remember is that the way that we have these surfaces designed with these crossing edges here, that's something that we want to continue as we bevel in to make the inset on the bottom of this piece. If we don't include that outside rim, we can bevel in and we can make these edges as straight as we want, add as many loop slices radial as we want. They're not going to get sharp on the corners. And if we include these crossing edges there, it's still going to give us an edge to define the actual physical edge, and then 2 edges to give us some sharpening of those edges and make sure that they stay a relatively sharp surface. All right, and I'm going to switch over to the top view now to do this, because I'm going to bevel, make sure that group polygons is on. I'm going to click in here, and then I'm going to move immediately to the scale tool, because if we try to scale in with the bevel tool, those tight edges are going to cross almost immediately, and we're not going to get the result that we want. But now I'm going to bevel this in, and I'm going to maximize my top view there. And I'm going to pull this in to where the outer rim is just beyond the outer rim of this button on the top, because we want to make sure that that will fit in physically when we put pieces together. So something like that will be just about perfect. There actually is a measurement of that. I think off the top of my head it's 1.6 millimeters. Actually, we can do the math. 8 millimeters minus 4.8 millimeters divided by 2, so yeah, 1.6 millimeters in, but more importantly, we want to scale this so that it's accurate to that top side. Then we're going to bevel again, and now we're moving up, so we don't have to move to a move tool or anything, because we can do that here manually. And 1.6 millimeters, if you remember, was the height of the button. However, we want a little bit of playroom on this, so I'm going to choose to go up to 1.7 millimeters. That way we won't get any surfaces overlapping. This won't matter unless we do clear pieces, but you know, many of the things that we're going to do, including the set that we're going to build here in this tutorial series, includes clear pieces. So you don't want to have clear pieces where you can see the top of the bump on one piece inside of another piece, and you actually see it crossing over surfaces. It's it's not going to look as realistic. Plus, if you put some pieces together and look, there is a little bit of clearance. So I'm going to choose to make that just 0.1 millimeters difference. So we have a little bit of space without it being, too much. All right, so now if we go back to subdivision surfaces, we'll see we do have sharp corners, but we have roundy edges this direction. So we're going to, again, add in some paired loop slices here and here. And that will sharpen that up. And now all we have left to insert is the little insert that is underneath. Now, that insert happens to be 2.4 millimeters in height, which is half of what this one is. So what I'm going to do is I'm going to copy and then hide this geometry and then paste. And now I'll be able to double click on that piece and move it down. And I'm just going to move it pretty much down until it meets 1.5 millimeters will actually meet exactly. Then I'm going to scale the whole thing down to 50%, because instead of 4.8, we know that we want 4.8, we want 2.4 millimeters as the height on this. And actually, you know what I'm going to do is I'm going to scale this back up to 100%. Actually, I'm going to go with 90% on the Y. And then I'm going to just drag it down. And at this point, I'm just going to eyeball this. We'll go back and adjust this properly here in a moment. So I'm going to drop the tool. I can unhide the top now. And let's see. Now we'll select this part again. The difference is we'll want this to be inverted. So I'm going to hit the F key to flip it. Now I'm going to grab these 9 polygons here and cut them. You can see we have a nice insert here where we can place this. So I'm going to put this, grab this edge and then this edge, and then once again we're going to run bridge tool, and we'll click in there. Sometimes you'll get some things going funny. It might look like this, in which case you'll want to use the reverse direction checkbox here. We can see it's actually working, so we don't need to check that here. All right. So now all we're left needing at this point is an extra loop slice here. Again, we've got 2 set, so instead of going and switching all my settings, I'm just going to put it in there and then go back and delete that piece there. And one thing we'll notice is that if we unsubdivide here, we have this loop and then this loop, and they're not going to be necessarily 100% flush with each other. So what I'm going to do is I'm going to scale this, and I want to scale it relative to this outer rim, which is the rim that we haven't touched yet. So I'm going to select all those, do my scale tool, and I'm going to set it to an element action center. I'll just click on this one, and just to make sure I'm properly up and down, I'm going to change my axis to auto, and then I'll turn off negative scale, and I'll just flatten this guy out. Oops, if it will let me. Well, something going on there. Let's get our location right, and then we'll scale this down to 0. That's just going to make sure that this surface is completely planar. Again, because we do have some, we'll have some high valence points here that we want to keep clean and we want to keep flat, so that our subdivision surfaces look flat where they're supposed to be flat, and then curved and arced where they're supposed to be. So there you have it. We have one simple piece started, and we'll use this now in the upcoming videos as the basis for making other pieces. So we'll come back in the next video and look at some theory on how to create other pieces using this one as the base. And then we'll also come back after that and work on some texturing and saving of presets before we move on to creating an actual set. If you have any questions, please feel free to shoot me a message, and I'd be happy to answer them. Thanks, and I'll see you in the next video.